Rate of change. Welcome to standard number 3 this year. Rate of change. How am I going to explain to you what rate of change is? Well, I'm going to use this fancy Lamborghini sports car that I just drew here. Now, if this car is driving down the road, the driver will be able to look at the speedometer and know how fast they're going, because every car I've ever been in has a little speedometer in there that says how many miles per hour they're going. Well, that miles per hour is actually a rate of change. It's telling the driver how many miles they would travel if they were to stay at that speed for 1 hour. So if you leave your house, you get onto the road, and you drive at 35 miles an hour for 1 hour, you'll be 35 miles away from where you started. That's what miles per hour means. And that's rate of change. It's how much are you changing and at what rate. So go back to the example of 35 miles an hour. If you drive for an hour and you're 35 miles away from where you started, your rate of change is 35 miles per 1 hour. That's how much you're changing per hour. Now, how it's usually written down is with a table, an XY table. Like we had a little bit of XY tables on the last test for substituting into a function. So with the table, you had an equation, and you had to substitute numbers into the equation for x to see what each value was going to be. This test is a little bit different. You're not going to see equations. You're going to see the whole table filled out for you. Yeah, you don't have to figure out any of those numbers. What you do have to figure out is from those numbers what the rate of change is. Okay, so let's go back to the miles per hour. Let's say x represents the miles, the hours, and y represents the miles. So let's say after 1 hour, you went 35 miles. After 2 hours, you were up to 80 miles from where you started. And after 3 hours, you were 100 miles away from where you started. Now, you can't just look at this and say, what's the rate of change? It has to be more specific than that. Rate of change has to be between two intervals of x. All right, so what was the rate of change between 1 and 3? Or what was the rate of change between 1 and 2? Or what was the rate of change between 2 and 3 hours? And here's the thing. It's not that difficult, but there's a really easy way to make a mistake. And here's the way to do it. From 1 to 3, what was the rate of change? I'm going to see this answer on a test. I've seen it every year, even though I try and stress to you guys not to do this, but I'm going to see the number 65. What was the rate of change between 1 and 3 hours? And people are going to say 65 because after 1 hour, you had gone 35 miles. After 3 hours, you had gone 100 miles. So what's the difference between 100 and 35? 65. 100 minus 35 is equal to 65. So people say, well, between 1 and 3 hours, you went 65 miles. However, rate of change is not just the y column. It's the x column as well. It's a fraction. The y column is the numerator. The difference in the x column is your denominator. So if you say 65, that's a whole number. And whole numbers you can turn into fractions by putting them over 1. So you're essentially saying that you went 65 miles in 1 hour if you just say 65 as your answer. But you didn't go 65 miles in 1 hour. It took you 2 hours to go 65 miles. So it's actually 65 over 2, which is like 37 and a half miles an hour is what you averaged over that time. But you don't have to turn that into something over 1. Just leave it as a fraction, reduce it down as far as it'll go. 65 over 2 does not reduce, so you can leave it as 65 over 2. All right, let me do these next couple for you. What was the rate of change between 1 and 2 hours? Well, that'd be from here to here and from here to here. So after 1 hour, you had gone 35 miles. After 2 hours, you had gone 80 miles. So you did a little bit, you were going a little bit faster that second hour than you went from the first hour, from 0 to 1. You went a total of 45 miles in that hour right there between 1 and 2 hours, because 80 minus 35 is 45. There's 45 difference between 35 and 80. And it was just 1 hour, 2 minus 1. So this is over 1. So the difference between the rate of change between 1 and 2 hours is 45 over 1, or just 45. Then how about the last one, 2 to 3? Well, from 2 hours to 3 hours, you went a total of 20 miles in a total of 1 hour. So it's 20 over 1. So three different answers for rate of change. That's why you can't just look at a chart or a table and say, what's the rate of change? It has to be more specific, and the questions that you're going to see will be specific. They'll say, what is the rate of change between these two amounts in the X column? So you might have more than 3 numbers here. You might have 5 numbers, and they might ask you, what's the rate of change between the second number and the fifth number? All right, just remember, the top number is the Y column. The bottom number is the X column. And that is also a source of confusion. People forget, they know it's a fraction, they know they got to do both columns, but they forget which one goes on top and which one goes on the bottom. So here's a little trick I try and explain to get people to remember which one goes on the top and which one goes on the bottom. And it's called rise over run, which I'm sure you've heard that term before, rise over run. Rise over run comes from a graph. It's often called slope, but we'll get into slope here in the next couple days. But rise over run means the y-axis over the x-axis. It means rising means going up and down, which the y-axis does. Running means going across, which the x-axis does. So rise over run is equal to y over x. So if you remember rise over run, which you have previously been told is slope, is y over x. Well, rate of change and slope are basically the same thing. If your rate of change is a constant rate, it's a slope, but we'll get into that later in the week. For now, I just want you to know that rate of change and slope, those words sometimes are used interchangeably as if they mean the same thing. And slope means rise over run, and rise is the y column that rises straight up and down. Run is the x column that goes across. So rise over run, y over x. When they ask you for the rate of change from an xy table, make sure you're putting the change in the y column on top. So from 10 to 22 would be 12, and from 4 to 6 would be 2. So your rate of change in this chart from 4 to 6 would be 12 over 2, which reduces to 6 over 1, or just 6. And that's what the problems in today's do section are going to look like. The chart is going to be given to you. It's already going to be filled out. Well, that might not be exactly true. There might be 1 or 2 problems where the numbers are in a paragraph, and they say, all right, the X column is these 3 numbers and the Y column are these 3 numbers, and you just have to write them into the chart yourself. But regardless, the numbers are going to be there. They're either going to be in the chart or they're going to be in the paragraph, and you just have to write them into the chart. So once you see the numbers in your table, I keep calling it a chart table. Once you see those numbers there, you can figure out what's the difference between any 2 given numbers in the y column that goes on the top. What's the difference between those same numbers in the x column that goes on the bottom? Y over x, rise over run. Reduce it, and you're done. There's your rate of change. So that's your basic introduction to rate of change. It's how much is something changing in a certain amount of time.